Alright, in this problem we have 6 carbon atoms, 12 hydrogen atoms, and 2 oxygen atoms. So when I was trying to figure out the structure of this particular compound, I have seen that there is a peak at around 174, which indicates that there is a carbonyl group, and you have a peak at around 60 ppm, which indicates that there is another carbon that is next to another oxygen atom, which indicates that there is a possible ester group involved. And then you have these peaks right here, which indicates that there is a carbon atom right here. And then you have these 2 peaks, which indicates that there are 1 or 2 possible methyl groups in this compound. So I went down further and analyzed the IR spectrum to give me more clues, in which I see between 2,850 to approximately 2,975. You got your alkane stretches, so your carbon and your hydrogens, in which I placed down below right here. And then at approximately around 1,750, you have the carbonyl group, in which it was indicated right over here in the 13C NMR spectrum. And then next, you have another significant peak right approximately up here at around 1,200 in the upfield, in which you have carbons that is bonded to this oxygen atom, but is a 2 single bonds. So I began to piece the structure together, in which in this chart right here of the 1H NMR spectrum, the 4.1 would indicate that there is a carbon right next to an oxygen atom, particularly a single bond like right here. And then you have these 2, which indicates there is a triplet and a sextet, which means that there is a carbon that is right next to these 2 structures right here. And then you have the methyl groups, in which they are very proximal to each other in the 1 hydrogen NMR spectrum. And that is because they are both methyl groups, in which they will appear on both ends. So if we look down here, and I completed a chart down below, in which I took into account the molecular formula, 6 carbons, 12 hydrogens, and 2 oxygen atoms, in which I have calculated the degree of unsaturation, which is 2 carbons, 6 atoms, and I had to add an additional 2 because of these 2 oxygen atoms present within this compound. And then you do minus 12 because you have 12 hydrogen atoms, and you divide all of it by 2, which gives you a degree of unsaturation by 1, which indicates that there is only 1 double bond in this compound. So as you see, from 2850 to 2,975, you have alkane stretches. From 1,750, you have a carbonyl stretch, a carbonyl group right here, and then you have 1,200, which is a carbon attached to an oxygen. And then from 13C, as you can see, the 14 and the 13 chemical shift we have right here, the 14 and 13 ppm, is due to the methyl groups, the CH3s, in which they're right next to CH2s. But there is a clear difference between the next 3, in which this carbon is right next to a methyl group and and a carbon that is within the alkane chain. And then you have this one, which is to the right, which is next to a CH2 and a CH3 on the left, which means it's possibly more shielded. And you have this one, which appears as 61 ppm, because this particular carbon is right next to an oxygen and is only next to one carbon, which is a methyl group. And then right here, you have a carbon, which is indicated as 173 ppm in the 13C NMR because it's within this, because it contains an oxygen atom which is double bonded, in which it is right next to another oxygen atom which is single bonded to. So one single bond, which gives it a high ppm, which is more downfield. Then you have a CH2 in the 1H MMR, which is right next to the oxygen, which appears more downfield, like in the 13C NMR. And then you have the CH2, which is right next to a CH2 and a CO, which is double bonded. And then you have the CH2, which is between this group and that group right here. And then you have a methyl group right here, which is right next to this only one carbon right next to it, and which is single bonded to this oxygen. And then you have a methyl group, which is right next to two carbons before you see the carbonyl group, which is double bonded to the oxygen. So due to this analysis, I have proposed that this particular compound indeed has 6 carbons, but it will have one double bond, which is up here, and an oxygen that is single bonded to 2 carbon atoms. Therefore, I have concluded that this potential structure is ethyl butonate as a result.